Hello and welcome back. And in this video, we're going to be creating our function within speech recognizer called transcribe. Now, this function is basically going to create SF speech recognition task that will transcribe the speech to text until we call this another function which will be called stop transcribing. Now, results for the transcriptions are continuously written and they're going to be published into the variable, the transcript variable or property that we have created. Okay, so let's go ahead and get started. We're going to create our function down here, and once again we're going to call it transcribe. Okay, and this function is going to first have a dispatch queue, and this dispatch queue is going to run on the background, and we're going to also give it a label. So we're going to create our dispatch queue, and actually, you know what, we don't need the main. We need to initialize this with a label. So the label is going to be speech recognition queue. Okay, and then we're going to define the quality of service, so QoS, and the QoS for this is going to be background, and we're going to asynchronously gonna execute the function. So execute basically whatever we're gonna write in this block. Okay, so it's not blocking the thread. Okay, now what we're gonna do inside here is first of all we need to get a reference to weak self, because we don't want to hold a strong reference to the self. And then what we want to do is we want to put a guard statement, first to extract self, second to extract the recognizer. When the recognizer is initialized and it is available for us to use, we're going to basically use both of them, and then we're going to basically start performing our task. Okay, so within this queue we're gonna basically perform the whole transcription. Okay, so let's start with the guard statement. In this guard statement we're gonna first extract self. Okay, and then we're gonna also get the recognizer. So recognizer is equal to self.recognizer. We also want to make sure that recognizer is available. So recognizer dot is available. Okay, so if all these conditions are true, we're gonna move forward from this guard statement. Otherwise we want to basically return or call out the error. So we're gonna call self, and in this case we're gonna call optional self, because it could be that this self is not initialized. Right here, the guard statement, the self is going to be available without optional right here in post guard, but not within the guard else statement. Okay, so we're going to call our recognition error, and we're going to pass the recognition error dot recognizer is unavailable. Okay, and we're going to return from here. Okay, so now we have our self. Basically from the optional we know that we can actually extract self and the recognizer. So we're sitting at this point where we can actually create our audio engine, or basically prepare our audio engine and also prepare the request. Okay, so we're gonna start by creating a do try catch block first. So do catch, and we're gonna come back to the catch in a little bit, but first thing we're gonna do is we are going to create a variable called a tuple variable for audio engine and request. Okay, and this is going to give us basically a audio engine, and the audio engine and the request basically, and the audio engine and the request are going to come from another function that we're gonna basically create, and this function is called prepare the engine, because there are a lot of components that goes in to creating the audio engine and the SF speech audio buffer recognition request, which is the request that we are calling here. Those two need a little bit of setup. So let's go ahead and create a static function, and we can actually call that static function to return the instances of AV audio engine and SF speech audio buffer recognition request. Okay, so we're going to create a private static. Okay, prepare engine is going to be the function name that we're going to call. This will throw an error if there is an error, and this will also return a tuple with AV audio engine and SF speech audio buffer recognition request. Okay, so these two we're gonna need for the transcription. First, we're gonna basically create an instance for audio engine, and this will be AV audio engine. Okay, next we are going to create our request, which is going to be SF speech audio buffer recognition request. Okay, and we're also gonna basically set a property on the request, and this property is called should report partial results, because we want to see partial results as well. Okay, so we're gonna say request dot should report partial result, and we're going to set this value to true. Next thing what we're going to do is we're going to initialize the audio session. So audio session, and this is going to come from AV audio session dot shared instance, and we're going to try to set the category for the audio session. So we're going to say audio session dot set category, and we're gonna set the category as record. That means this audio session is for recording, and mode we're gonna set is going to be the measurement, basically indicating that you're performing a measurement for audio input. Okay, and we're also gonna provide the option where we're gonna say duck others. That means it's basically if there's anything else that is going on. For example, there is a map session going on, and where you have navigation currently in play, and some direction is being spoken. When you start recording your own voice using this app, then the voice for the navigation or any music playing will be reduced. Okay, so audio session can basically listen to what you're trying to say. So that's what duck others mean. Okay, so we're gonna set this category, and then once we have the category set up, then we're gonna activate basically the audio session by saying audio session dot set active is equal to true. And we also want to basically provide the option where we would notify others on deactivation. So the normal session, for example, if the navigation or music was playing and we actually reduce the volume, then others can basically resume their normal operation as soon as we are done recording. Okay, so we want to notify others on the deactivation. Okay, and then we're going to basically extract an input node. An input node basically is extracted from the audio engine, so we're going to create that, and then we're going to create our recording format. Okay, so let's go ahead and create recording format, and this is going to come from input node, and we are interested in output format for bus on the 0th channel. Okay, and then we're gonna take our input node and install tap on bus. Okay, and once again, bus on the 0th channel with the buffer size for the recording is 10.0.1024, and the format is going to be the format will be recording format. Okay, and Okay, so format, and then we're gonna have a closure here. Okay, so this closure is basically going to have, we're gonna receive a buffer in this closure. So buffer is gonna be AV audio BCM buffer. Okay, and this also it also receives the time for the audio. So we're gonna get the time in AV audio time format. So AV audio AV audio time. Okay, so these two variables we actually get access to in the closure, and we are going to basically take our request and append the buffer. Okay, now we have the input node ready to go, and our audio engine is also ready to be prepared. So we're gonna simply call audio engine.prepare, and then we're gonna basically start the audio engine. Okay, now here we're gonna return the instance for the audio engine that we have created, and also the request that we have created, and that's what we were actually getting a reference down or up here in the do blog. So we're gonna create our let. We know that this function returns a tuple, so we're gonna create audio engine, a variable, and another variable called request, and we're going to try capital S self on the prepare engine, and that is going to return us the audio engine and the request, and we're going to assign self.audio engine to the audio engine that we have received, also the request that we have received. Okay, now we're gonna say self.task that we have created. Let's initialize this with the recognizer dot recognition task. Okay, and recognition task takes a with, and it basically takes a result handler. So let's identify the one that takes the result handler. There we go, this one. And the with is basically where we need to pass the request, where recognition task is going to start with the request that we have created, and the result handler is going to give us the speech recognition results, and if there's any error that has been encountered during the recognition. So we're gonna put this in a variable called result and error. Okay, now what we want to do with these is once we have received the results, we're going to check if the result is final. That means Apple on the servers, they're going to be processing these voice inputs, and they're going to try to figure out using their machine learning model what's being said and what's being transcribed is correctly mapped. Sometimes you would say something, an audio engine hears something else. It transcribes what it hears, but it could be wrong. So using ML, Apple actually tries to figure out what is the logical word that could fit within that sentence. So they would actually try to replace that, and that's when we actually get the result as final. So we're going to basically get the result. So we're going to receive received, we're going to create a variable first, received final result, and we're going to basically store this inside the result dot is final if it is final. Otherwise we're going to basically set the result, set the received final result as false. So if it's not final, then we're going to put the false value here, and also if there's any error, then we want to actually store that as well. So let received error is equal to error is not equal to nil. That means there was an error. Okay, now we're going to check both of these. So we're going to say if the received final result or received error, if either of these are true, then we want to stop the audio engine. We want to set the input node and remove the tab. Okay, and we actually don't need to do this because we're going to actually call the reset in the catch. Okay, and but if the result we receive and we can extract it out, so if let result is equal to result. Then we want to basically put it inside the transcription. Okay, so basically we want to create a function, and this function is basically going to be simply setting the transcript message. So we're going to say private function called speak, and this is going to have a message that it will receive. This message is going to be of string type, and it'll simply set the transcript with the message. So we can just basically call this function, and we can reuse this function over and over. So if there's any other condition that we want to actually check here, we can actually store or set this conditional as well. That's why we have a separate function here. So we're going to say self.speak, and we'll pass the message, and what we're going to do is we're going to get the results and get the best transcription out of that and put it in a formatted string format. Okay, so it's going to give us a formatted string from the best transcription that we have received from the Apple server. Once again, all these audio sessions, they go to the Apple server, and then they get transcribed. Okay, so so this is all the work that you need to do inside the do block. Now inside the catch block, we are basically going to reset our state if there's any error that has occurred. We also want to make sure that we report these inside the recognition error, so we can see what kind of error that we have received. Okay. All right, so with that, we have actually completed all the transcription. There's one thing that is left, and that is basically the stop transcribing. So whenever we want to basically stop the transcription, which is going to be the stop button, which is going to call this function, we want to make sure that we reset all these states. So we're just going to create another function here, and this function is going to be once again called stop transcribing, and it'll simply call the reset function. And reset function is basically resetting all these states, essentially stopping any ongoing task, stopping the audio engine, and setting all these states for the audio engine. Okay, so yeah, so this is all we're gonna need basically to recognize the speech and convert that into a text value. And with that, we have reached the end of this video. In the next video, we're gonna continue to build this app. So I'll see you guys there. Thank you.